Dear all, in this period, we will solve few more questions related to midpoint theorem. In a parallelogram ABCD, E and F are the midpoints of the sides AB and CD. So these two sides are equal. These two are also equal. Because it is a parallelogram, AB is equal to DC. Opposite sides of a parallelogram. And E and F are the midpoint, so we can say that FC is equal to half of DC, which is the same as AE. Half of opposite sides, half of DC and half of AB. Also, FC is parallel to AE. Again, opposite sides of parallelogram. So we find that AECF is a parallelogram. Because one pair of opposite sides are equal and parallel. Now let us consider the triangle. We found that these two are parallel. This side is parallel to this side. Now let us consider the triangle DHG. We can find GF is parallel to HC. Because it is a side of a parallelogram. And by the inverse of midpoint theorem, we can see that G is the midpoint of DH. Because the inverse of midpoint theorem says that a line passing through the midpoint of one side of a triangle parallel to the third side bisect the second side. So we can say DG is equal to GH by inverse midpoint theorem. So we found that DG and GH are equal. Now we also have to show that GH and HB are equal so that DB is equally cut into 3 equal parts. That's what we have to prove. Now for that, we have to consider the triangle ABG. In triangle ABG, also we know that HE is parallel to GA because it's a part of a parallelogram. So again, by inverse midpoint theorem, we can see that a line passing through the midpoint parallel to the third side bisect the second side. So GH is equal to HB by inverse midpoint theorem. So let us name this is equation 1 and this is equation 2. So from 1 and 2, we found out DG, GH, again GH, HB, so they are the same. DG is equal to GH is equal to HB, or the line DB is trisected. Therefore, the line DB is trisected by the line AF and AC. All right, moving on to the next question. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. So first of all, we just know that this is a quadrilateral ABCD, and we have the midpoints E, F, G, H. So these sides are equal, but each part is different from the other. Okay. Now, the main question is to show that The line segment joining the midpoints of the opposite sides of the quadrilateral bisect each other. Means the line joining E to G and H to F is cut into two equal parts. That's what we have to show. For that, first of all, let us prove that EFGH is a parallelogram. For that, in triangle ABD, we know that E and H are the midpoints. So EH is parallel to BD and EH is half of BD by midpoint theorem. Again, from the triangle BCD, we find that FG is parallel to BD and FG is half of BD. Let's consider this is condition 1 and this is condition 2. So from condition 1 and 2, we can see that EH is parallel to FG and EH is equal to FG. Because the right sides are equal, we can say left sides are equal. So we found that EH and FG are parallel and they are equal. Therefore, EFGH is a parallelogram. One pair of opposite sides are equal and parallel. Now we have to show that the line joining these two corners, which means EG and FH are bisected. We know that in a parallelogram, diagonals bisect each other. Therefore, EG and FH bisect each other. Which means these two are equal, these two are equal. Well, moving on to the last question. ABC is a triangle right angled at C. So we have a 90-degree here. A line through the midpoint M of the hypotenuse. So this is the midpoint, which means these two sides are equal and that is the hypotenuse, parallel to BC. So these two are parallel. Intersect AC at D. We know by the midpoint theorem, M is the midpoint and DM is parallel to BC, which means D is the midpoint. So we can say that since M is the midpoint, and DM is parallel to BC, we can say that D is the midpoint by inverse midpoint theorem. What was the inverse midpoint theorem? A line joining the midpoint of a side parallel to the third side bisects the second side. So we found out that D is the midpoint of AC. Next, we have to show that MD is perpendicular to AC. MD is perpendicular to AC means we just have to show this is 90-degree. We know DM is parallel to BC. So if two lines are parallel, we have the corresponding angles are equal. So ADM is equal to ACB. Angle ADM is equal to angle ACB. Corresponding angles between two parallel lines, DM and BC. So we already know that angle ACB is 90-degree. This is 90-degree already. So angle ADM is 90 degree. Therefore, MD is perpendicular to AC. So the second part is proved. Next, we have to show that CM, so we join C to M, is equal to MA. These two sides are equal, which is equal to half of AB. This is already shown in the question. Because M is the midpoint means it is half of AB. This is done. Now you have to show that CM is equal to MA. For that, let us consider two triangles. In triangle ADM and triangle CDM, we have angles equal at D and C. Angle ADM is equal to angle ADM is equal to angle CDM. If one side is 90 degree, the other side will also be 90 degree because it forms total 180 degree because of linear pair. Now we've proved that AD is equal to DC, proved above. And side DM is common. So we have side, angle, side. By SAS, triangle ADM is congruent to triangle CDM, which means AM is the same as CM. Therefore, AM is equal to CM. But AM is equal to half of AB. Therefore, altogether we get CM is equal to MA is equal to half of AB. Amazing, right? Well, then that's all for this chapter. And in the next period, I will come up with a summary of all the properties of parallelograms, which will make you easy even to apply in the coming lessons too. That's all for today. Good luck and have a wonderful day.